Okay, can you see presentation? Credit data sets? Hello, can you see?
No, no, nothing is showing yet. Your screen is not shared yet.
Let's go 1 second. Can you see now?
Yes, we can see your screen.
Can you see greedy data set presentation?
Yes, we can.
Okay, thank you. Okay, I know. Sorry. Okay, so we need different data sets. I said that we have different option uploading to database. This is weather data set template, and all templates for different data sets you can get from the Craft interface by the option download template that will be activated when you select special resolution and level you are working with. All template at the top contains information about the column headers and example. That starts, the row starts with the pound symbol, and these rows at the final stage, you need to delete and just leave the content, the data itself. Same is true for soil profile, soil mask. I mentioned that soil profile file should be in DSSAT 07 folder and soil subfolder. Generally, file name consists from 2 letters, as in this case, ML. It has extension SOL. This is the one soil profile. This is the second soil profile, just example. This is extract from the entire soil profiles file. And you need to upload them in the Craft database before you will start simulation. So configuration, you load soil profile, you select that file and start uploading. Depending how many profiles do you have, it might take time. We tried yesterday to upload about 8,000 soil profiles, and it took about 20 minutes, 25 minutes. So be aware about that. After you have uploaded your soil profiles, you should additionally have soil mask. Soil mask contains cell IDs, soil profile ID, and share percent. I said that there was a publication and there is tool available to preparing soil profile data. It is called START. Please try to download it and let me know if you have any questions regarding that. This is the example of crop mask on top. So crop mask contains cell ID and share percent that occupied by a crop per grid cell. Additionally to that, there is a second soil profile necessary to have that contains information about crop variety. So you should have cell IDs, you should have cultivar or variety ID, it is called cultivar ID here, and share percent. Again, whenever you have share percent, then you can split grid cell between different, in this case, crop varieties. Some other case might be soil profile or fertilizer application, etc. This code available through DSSAT genotype files. Each crop has its own sets of genotype files. You can check on that and find out what the code is for particular crop variety. Planting. As you saw yesterday, we entered planting related information into different way. One from interface. That means that it will be same for each grid cell. But another more flexible option is prepare the planting mask as it is here, shown here, with cell IDs and minimum required information, such as planting date, plant population per square meter, planting method, distribution, planting depth, in order to have later simulation per grid cell. This is the example. Pay attention that planting date, we need entered here in the format month and day. Month and day. So this is planting. Okay, we tried yesterday all those data sets. I provided some example. Crop variety, crop mask, soil profiles, etc. But we have not done with fertilizer. And this is the template related to inorganic fertilizer. Similar is organic. I will just briefly review inorganic fertilizer template. Again, you can download this one when selecting data type as fertilizer. You can select as well resolution and your area of interest, and you will get this template. Template will contain your actual cell IDs. As you can see here at the bottom, column are empty because no data was entered so far. You can see actual cell IDs from your schema file. And then again, we have the with pound comments. Here is the example. Every template at top contains the example. Pay attention that everything is tab delimited. This symbol arrow, it shows the tab delimited. And below is the example that we will cover shortly. So this example contains cell IDs, then level, fertilizer application date as F date, and you can see on top, this is fertilizer application days from planting, F date. In this case, we have two split fertilizer application, you see, same cell IDs, level 1, and then comes two application dates, 1932. Then comes the FMCD code, which is the fertilizer application code. FMCD, yeah, fertilizer material code, sorry. Then comes FACD, fertilizer application code. First one is this code is for urea. Another one is broadcast incorporated application. I showed yesterday file where you can find those codes. The file is in the DSSAT root directory, the file called detail.cde. There is a section where I will shortly show that one again. It's called fertilizer. And in that section, you can find that code. Then comes FDEP, FDEP. This is the application depth, 5 centimeter in this case. Fertilizer application amount, FAMN, 18.9 kg nitrogen per hectare. The rest information is not necessary. You can enter 0 or -99. And finally, at the end, those are optional. And at the end, you can find percent fraction. So at per grid cell, you might have different percent of a fertilizer application. And again, for the next cell, the same application, fertilizer application, two-split application is applied. Again, we have two rows, 1932, after planting date, and then comes same value, and etc. So in this extract, you can see the cells with same fertilizer application, but down in the file might be some other values as well. Okay, let me stop this brief information. Let's run craft. Run everyone craft. And follow what I will do. Can you see my screen? It should be craft interface.
Yes, it is.
Thank you.
Yeah.
Thank you. Again, let's try first, go to the in main menu to management option. Management. We define inputs through the interface first to understand what values can we enter. Define inputs. We tried already field, crop variety, planting. Let's go to the fertilizer and inorganic. This is the screen window you will get after invoking that menu option. It's empty currently. On top right, there are options working with the values, adding, editing, delete. Click add. Activated panels below for level, for that level. Input data format is days after planting. So please pay attention to this. So days after planting. Later, we will enter a value for description. Days after planting, let's consider 19, next one. Then in the next field, you can see the fertilizer names. Then you click this one. Somehow I have my screen messed up and it one pops up on another screen. So in your case, just click on that one, find urea, press U, you go to that item and select urea. In the next field, please select Broadcast Incorporated. Broadcast Incorporated. Leave other element as it is, 0. Depth, 5 centimeters. Nitrogen amount, let's take 19 kg per hectare. It's nitrogen elemental content. And below is the save application button over here. There is a clear, there is a delete. Save application. That means that it will save these values as the application values. Save application. And it will show up here, application dates. So first application, 19 days after planting, we are using your method of applying is broadcast incorporated. Depth is, when you select this one, depth is 5 centimeter, amount is 19 kg per hectare. And save application. Okay. When you click save here, this one will be entered as level 1. Save first here, then save. Description we missed. So everything that comes with the red star asterisk, it should be, it is necessary and you need to provide the values. In this case, let's put it that way. So this is urea. I leave this one as it is. Save application and save. You can see it shows up here. And you select those activated with this one. Let me edit. Now I will try to add one more application that we had to split. Second one will be 1929, same. Urea. Again, incorporated. Depth 5. Amount same. Only difference is between date of application. Save application. And again, save this level. Update is successfully. And we have this one here with 2 split application at days 19 and 29. Urea broadcast incorporated. That's how we can enter fertilizer application. Now let me bring another option for entering. Please mute your microphone, Isaac.
Isaac, please mute.
Another option will be applying the fertilizer application template. I will upload this template on share folder in Google. Please, everyone, check fertilizer folder on Google Drive. There is a one file in that folder. Download that file. Can you see the file content on your screen?
Yes, yes, it is the fertilizer CMDT.
Okay, thank you. Thank you, Glenn. Okay, let me briefly touch to this content. Again, we have the cell IDs for our case. This is entire CMDT region. As you can see, we have level one. Level one consists from two splits. The similar values that I just entered from interface, but there are some other levels as well. For example, you see 4 is a level 4. Let's compare what are difference. Here application data are 24 and 36. The rest is the same. So application date is varying. Let's see what's going here. Level 3, number 3. Again, different planting date and value is different as well. So application values varies as well. We have the 18.9, we have 16 point, etc. And in this case, we have 19.8. So this crop mask allows us vary the application rate, dates, etc., all values over the grid cell. Okay. Now I will upload this as we've done before, the same way. Data, import, user, select the special resolution, data type. These are all the data types we can upload. Fertilizer, inorganic, as I said in this case. From the list, we need to select the area of interest. In our case, this is the CMDT file prepared for entire in this region. Then we need to select the file itself. Usually, I'm selecting the file name as dataset tag. This one. In order later we are able to select by the tag name dataset from the interface, craft interface. In the same text, I will apply as a description. Again, resolution, country level, data type. We need assign tag, data tag. Indicate folder where file is located. Provide description. Here you can see download template for this fertilizer dataset. Click upload and file data uploading. Two datasets that can be entered only from interface are field history and another initial conditions. We tried with the initial conditions to provide those data sets. Now let's try to do the same for initial conditions. Again, we need to select menu option, management, define inputs, initial conditions. Lori, could you please confirm again that you can see my screen?
Yes, we can see your screen.
Okay, initial conditions. Add, it's empty, we don't have any level here. Add. Those are the fields, and you see that red star, so we need enter all those information. Let's leave by default root weight. Let's reduce total residue to 250. Those are the initial condition before planting in the field. And residue as 0.8%. Incorporation percent 50. Incorporation depth 5. Let's assume available water at 20% level. And nitrogen amount per hectare 8 kg. So somehow from different resources or expert knowledge, you need to clarify those value and provide. But that's optional. You can make simulations without initial conditions, as we have done it yesterday. Just you need to start from 2 weeks up to month earlier simulations in order for that planting date model adjusted those values. Some descriptions or initial conditions, for example, 250. You can just list those values here for clarity. So this is the residue, root weight, 100, etc. Save. Okay. Now let's select the project that we ran yesterday. Second, this is the different run actually from the same project. Select the one of them. I will activate. And I will create new run. Again, we are working with Maze. Engine. DSSAT. Data sources are custom. We are creating those ourselves, not default, existing in the system. Maze. We are running for small region, which was called Kotiala and sub-district Kotiala. We use here initial conditions and fertilizer. So let's make it run 3. Save. Okay. When you have system default data, you need to check those checkboxes, but we don't have one system default. And second, we prefer to work with our dataset. Let's select soil. There is one soil-related information, can be more, but this is what we entered. Weather. For weather, we have 2 selections. CMDT we entered, but it contains limited data, right? We just tried, and we entered only 10 weather files. That means only 10 cells contain weather data. But I uploaded that complete data set for all grid cells, and it's called INEX version 1. It's in dataset. You can export if you need those dataset as well, but currently it's in dataset itself. We are not irrigating. Crop mask. Let me upload the crop mask as well, because I missed that one yesterday. It will consider that crop occupies entire grid cell area, if not indicated here, and it will work. But let me quickly do that one as well. Input, user, special resolution 5, data type, crop mask. You see, there is a crop variety and crop mask in this case. Base. You can skip this uploading of crop mask, but I will do this as an exercise. Here, crop related data. This is the crop mask. Data type, crop mask, base. Okay, so special resolutions, country, type, tag, crop selected, we indicated where the file is located, everything is here. We edit description and upload. Okay, now let's go to select. This is we are working. Let's go to the data source.
Hello.
Can you repeat this one? Yes, I can hear you if any question.
Okay, I wanted to know which folder you selected for the description. No, for the browse, sorry.
For what?
For the crop mask. You selected a certain folder. I
Yeah,
wanted to know which one.
that's how that I have in my local computer,
No,
and I
and I was
select.
saying that one.
Yeah, I will
You send it.
upload. Yeah, I will upload that file on Google Drive, and it will be
Oh.
accessible for you. But for now, as I said, you can just skip this one. It's not necessary for
Okay,
the exercise.
okay,
I'm
thank you.
just showing that it can be done that way.
Thank you.
Let's select crop variety mask. We have just one variety. And next selection option we have here is fertilizer. You can see fertilizer. We have not done before. Can be done from interface, or you can upload from the file. Let me select the file. Planting. Again, we can select from interface. We've done that level, we are entered, or we can select from file, which is more flexible and more detailed. Field history should be from interface. That's option we have, only option. And the initial condition also can be from interface. That's also, we do not have much choice there. So everything except field and initial conditions are provided through the masks and detailed information, as you can see from this selection. Now, pay attention why I am giving tag when we are entering data set. The tag always show up in this list. As many you will add, and you might have different versions. So all for planting will show up here. All for fertilizer will show up here. And you need to give reasonable names to this tag, indicating version number in order to make differences, which one you would like to work with. Save. Okay. Next. And as you can see now, we need to indicate only two things: field history or initial conditions and initial conditions. In both cases, we just have one level, can be more. Let's select one, initial conditions. And those are the values on the right side here that I entered. Let's select this level, apply. And we are going next screen where we are indicating the start year, end year, start of the simulation. We can select output variables, output statistics, etc. So let's limit our simulation as we've done before to 2 years, starting 2000, ending at 2001. I will change end of the simulation date from the various plant dates that are in this planting mask. It will select the earliest one. It might be different, but here it will indicate earliest one. You remember that I said that when I don't have initial conditions, I can start simulation earlier. Okay. I have initial conditions, but still I will try to start earlier, 2 weeks earlier, in June 5th instead of 19th. We have maturity. Last time we selected the precipitation. Let's select top weight. We have 2 output variables. I had mean. Let's select standard deviation as well. 2 output variables, 2 statistics. You can select more. As many you select, it will take more times the simulation. That's all the case. Save. And if everything is correct, then we'll run this simulation successfully. So we can see cell processed, how many are successful. So far, all of them are successful. As we have a limited number of cells, it will finish relatively quickly. Completed, you see 1% completed. There is a 1 cell with error. We need to save results. Result saved. We can view results this way. As you can see, output variable is maturity, yield at maturity. We can see another one as well, tops weight. When you click view on map to show those values, it shows in this case statistics as average mean, but you can select standard deviation or tops weight. Again, you can change classes and you can see also map. All input values are hypothetical. So when you are working, you really need to dig what's going on, why these values are that way, etc. Okay, that's related with fertilizer application, entering, masking, fertilizer, etc. And we did this as additional run for the same project. Again, we have the option compare. When you have this first one as selected for comparing to others, then you can select another project from here, not this one, because not all done for this. And then you compare. So number of statistics, Is something wrong in a second. Not standard deviation, but I will select mean. I will select maturity, and then I will go to the compare results. I have one. Yeah, not sure what happened, but somehow it's not showing. I'll be related with database. Okay, let's move on.
Sir,
Yes, yes.
is there any way to export data in CSV from?
Could you repeat, please, your question?
I said the result, is it possible to save it, to export it as CSV?
Yes. Yes. Can you see here at the end of the screen?
Export grids.
Export grid
export
cell,
grid.
export grid one. Let me export the aggregated one.
Relation.
You see?
Okay.
This is the XLS file. You'll get XLS,
Okay.
and then you can convert CSV or whatever you like.
Okay. Thank you.
Okay, let's move to the next topic. On Google Drive, I'm uploading right now, observed yield values. Please download that one. And then we will go to the next project. On shared folder on Google Drive, I've just uploaded observed yield values file that contains those values. Please download that one. I will share that file content with you. That's the file. Please download that from Google Drive. Again, template from observed yield you can get from here. Import user, special resolution 5, data type, observed yield. Template is activated, and you can download template. That's the file I have. It is tab delimited again. Column header year and values. Then second column should be called this way. And I have values starting from 1990, finishing up to 2014. This is the regional yield values for our region of interest, Kotiala. Maize yield values, 1800, 1300, 1900, etc.
Good morning, ABE. Please join us now in Fraser Roger 122 for Robert Morton.
Please download everyone, and then we will try to upload it as I already have. So data, import, 5 minutes. Observe it, country, CMDT, Level 2 is Kotiala. Start year 1990, as you noticed. And the year that I had was 2014. Data tag. I will again select the file name. And copy the same as data source in this field. Data source, will copy that one. Crop is maize. Season. It is necessary to select this. We are not using actually for simulation, but select any of them. I will select file itself. It's on my desktop. In description. All fields are filled. So pay attention, that should be start year and end year. This is the first year I have the data. This is the last year I have data. This is the start end. We are working with third level, the small region called Kotiala, and upload. Let me move this file some other location. I hope everyone was successful. And let's move to the new project. Create. Calibration. Next project we will consider, this is the calibration type project. So again, as I'm calling project, this is Kotiala. Calibration. Version 1. Special resolution. We need to identify the hour level from selection. When you press on your keyboard first two letters, it goes directly to that item. So this is the project related information, as you might remember. Project name, type description, domain, resolution, save project related information, okay. And new type of window will show up. So observed yield, and generally the observed values over the years might contain certain trend related, in most cases, improvements in technology, updated, new variety, new agricultural technology methods applied in the field, etc. So the yield values might contain trend. So in order to remove trend, there is an option how to do this one, and exactly in that screen we are right now. If you have not uploaded yield to this moment, you can do this from here, upload observed yield. You can select crop. This is maize. In this field, you need to select the observed yield data. You remember how we uploaded this one? The name might be several. The trending method, I will select linear. Click OK. And it will show the trending results. So the idea behind is that bring the yield values to the technology level of the last year, 2014. In order further using of those values as the reasonable. We are not changing technology over the years during the simulation, right? So somehow we need to consider that. The trending allows to do this. So we are considering after the trending that those yield values are the levels in the current technology. In this case, last year, 2014. Click OK. And now we are proceeding to the calibration process. Select engine. We are working by default with DSSAT. That's the main crop engine. Custom. We can select model. Currently for maize, it had just one model here. And this is one. Save. Okay. And we came to the input window. We are indicating soil, weather, crop mask, crop variety, fertilizer, planting, field, initial conditions from the interface. So all the inputs should be close to the situation you would like to work. All inputs. And those same inputs, then I will later use the for yield forecasting. Those should be similar inputs, same inputs. Save. Next. Okay. Again, this window always shows what we have from interface. Yield history, initial conditions. And here we need to make decision. Start and end of the year. As our data, observed yield data, are available from 1990, we should start from 1990. And we have additionally weather data starting from 1981. So we can start from here. We have everything to make the simulations. And there should end up in the last date when observed yield are available. So 2014. Date of simulation, 2 weeks earlier, month earlier. The rest I'm leaving as it is. Yield at maturity, average values, saving, okay, and running. So calibration process is very important, generally in crop modeling. For the field level, when we are making calibration, We are using the yield values for several years, different environment. And then based on those data, we are calibrating cultivar coefficients, nicotide coefficients for varieties we have. But then we are making the simulations on the big scale, large scale, and the spatial extent is quite big. It is impossible to consider for each field to calibrate genotype coefficient. So this approach, calibration simulated yield against observed regional yield, is the usual approach we are using for this case. After this simulation, we are getting so-called modification factor that allows simulated, not a simulated value, is using this modification factor, calibrate to the final values of the yield. That's the sense. If you think that you don't need the calibration, then you can skip the calibration process. And the trending as well. Both calibration and the trending are optional, and depending on your goals, in your approach, how you want to solve your task, you can consider them or just skip one or both. Shortly, we will see the results, and I will give some more details as well. As you can see, simulation takes a little more time. Why? Because we are doing simulations almost for 24 years, right? It starts 1990 and it ends in 2014. The total number is shown here, 25. We are making 25 simulations. Each simulation, 75 grid cell or 75 fields as you would prefer. Grid points. We have one cell with error. We are not checking the errors. We are short in time, but some reason might be it can be on the border. Some others. Save the results. I'll save, view results. View results, and this is the outcome. So in this case, modification factor is just one. So how it is calculated? So we have the pseudo yield or simulated yield, horizontal line. On vertical line, we have the trended yield. And we are trying to find the line that goes over the intersection of this axis to 0 point here. And at the same time, it's close to observed values. So root mean square should be minimum, and it also should intercept this one. And the slope of this line is 1, it is close, as you can see, very close to this one. But in some other cases, might be more than 1 or less than 1, etc. So in this case, it will be just multiplication 1, same way, calibration. But remember, our values, we just using different combination without any analytics why we are using one or another. Just example exercise. So this is the calibration run. The next step, we go to the yield forecast, but let's make a 5-minute break. I will check with my monitors why I'm experiencing problems, and then Stop sharing here.
So we do a 5